Hey everyone, let's talk about the HTTP protocol. We will cover what HTTP is, why it exists, the anatomy of how it works, the methods it uses, a concrete curl example, and a summary. Part 1. What is HTTP? The foundation of APIs. HTTP is the Hypertext Transfer Protocol used as the transport layer for virtually every API on the internet. Now, while it was originally designed decades ago just to fetch basic web pages, it has completely evolved. Today, it's the invisible workhorse that's literally carrying the data for the complex applications you use every single day. Part 2. Why HTTP exists. The language of APIs. You see, modern applications aren't just single blocks of code anymore. They are dozens of independent systems all trying to interact at once. HTTP exists to provide a strict, universal language that allows independent software systems to communicate without ambiguity. By standardizing the requests coming from clients and the responses going back from servers, it completely eliminates confusion between disparate software systems. It's essentially the universal translator for the web. Part 3. How HTTP works. Anatomy. The structure of communication. Every HTTP interaction has two sides, kind of like a two-way street. On the outgoing side, you have the request from the client to the server. This contains a request line with the method and URL, a host header to identify the target, metadata headers, and an optional body for your data. On the incoming side, the server's response essentially mirrors this structure, but it swaps out that request line for a status line to tell you what happened before delivering the returned body data. Part 4. How HTTP works. Methods. The verbs of the web. These HTTP methods act as semantic verbs. GET retrieves a resource. POST submits data to create a new resource. PUT replaces the entire resource. PATCH updates specific fields only. DELETE removes a resource. Using these specific verbs correctly is absolutely crucial. We categorize these verbs into two really important buckets. First up are safe methods, meaning the request has no side effects and does not modify data, like a simple DET request. Second are idempotent methods, meaning calling the same request multiple times produces the same result as calling it once. GET, PUT, and DELETE are all idempotent. POST is not, which is exactly why a network timeout on a POST request can accidentally duplicate a payment or an action if you retry it. Part 5. How HTTP works. Status codes. The response language. So how do servers communicate results? They use distinct families of 3-digit status codes. The 200s mean success, while the 300s handle redirection. Now, if you see a 400-level code, that indicates a client mistake, meaning you made a syntax error in your request. But if you hit a 500-level code, that indicates a server failure. Your request was totally fine, but the server itself crashed or failed while trying to process it. Understanding the difference between two very common 400-level errors is a real game changer. Let's use a security guard analogy. A 401 unauthorized is like walking up to a building and you have no badge. The server does not know who you are. You lack authentication. A 403 forbidden is when you have a badge but no clearance. The server knows exactly who you are, but you lack the specific authorization or permission to perform that action. Part 6. A concrete curl example, practicing the language. To see this in the real world, developers often use a terminal tool called curl. Here, a simple GET command retrieves data from a URL. By adding the verbose flag, or -v, it exposes the full HTTP conversation, literally letting you see the exact request and response headers passing back and forth behind the scenes. To modify data, we just switch verbs. This POST command uses headers to define the JSON format for the server. It then attaches a body payload to submit that data and instantly create a brand new resource. It's the whole shebang. Methods, headers, and bodies working together. Part 7. Summary. The definitive synthesis. HTTP is the foundational language of APIs, requiring precise grammar through methods and status codes to ensure reliable, structured software communication.